So the U.S. Substance Abuse and Mental Health Services Administration conducts surveys on drug use by type of drug and age group. According to the publication, 13.6% of 18 to 25-year-olds were current users of marijuana or hashish in 2000. In a recent poll of 1,283 randomly selected 18 to 25-year-olds revealed that 205 currently use marijuana or hashish. At the 10% significant level, do the data provide significant evidence to conclude that the percentage of 18 to 25-year-olds who currently use marijuana or hashish has increased from the 2000 percentage? In this case, I'd like to use the p-value approach. So again, we have to double check and make sure of a few things doing our hypothesis testing. First, we need to make sure that some of the requirements are met. So recall that n and p0 and n1 minus p sub 0, we need to verify that both of these are greater than 5. So let's first state our null and alternative hypothesis. So step 1, we need to come up with a null, and we need to come up with an alternative hypothesis. So let's take a look. Do the data provide sufficient evidence to conclude that the percentage of 18 to 25-year-olds who currently use marijuana or hashish has increased? Is that going to be the null or the alternative hypothesis? Survey says. So what's my alternative hypothesis? P is greater than 13.6, but again, we'll write these in decimals. So 0.136, so our null hypothesis is going to be what? Survey says P equals 0.136. So now we come over here, now that we have our null and alternative, and we just have to check that 0.14 times 1283 is greater than 5. Yeah, I think that's pretty clear. And we have to check that n times 1 minus p sub 0, well, 1 minus p sub 0, can we agree, is about 0.87? Say yes. Thank you. So 0.87, so 80% of 1283, can we agree that that clearly is going to be bigger than 5? Okay. So the checks have been made. We can proceed. We're in the large sample size case, so we can carry on. So step number 2 is to compute our z-test statistics. So z equals to, oh, wait a minute. We got to come up with some information first. We need x and n. Or, yeah, x or n. So x in this case is going to be what? 205. And n in this case is going to be 1283. Excellent. So z equals 2, so it's going to be our p hat. So 205 divided by 1283 minus p under the null hypothesis, which is 0.136, times the square root of n, so that's the square root of 1286, divided by the square root of 0.136 times 1 minus 0.136. Yes. I don't know why I put a 6. I guess I was just excited. So we need to compute this z-test statistic. So I came up with 2.49. All right, continuing on. So we have step number 3. So we have to come up with our standard normal distribution. And we're doing p-value. So to compute the p-value is going to equal to the probability that z, now let's see, what do we got? An upper-tailed test? So z is greater than 2.49. So this is the normal CDF. So our lower bound is going to be what? Our lower bound is going to be what? I'm getting scared. 2.49. Z is greater than 2.49. I think this brings up a really good issue, and thank you for bringing this up. So remember, this in the direction of the alternative is the p-value. So it doesn't hurt to sketch this out. So the lower bound, so now that we can see this, remember this is the 2.49. So the lower bound 2.49, E99, so positive infinity. I believe that's all we need. So I came up with 0.006. So step 4, we need to compare the p-value, 0.006, with our alpha level. Do we have an alpha level? There it is. 0.1. So what can we conclude? 0.006 is less than 0.1. So what is our decision? Reject the null. Excellent. Okay. So what does it mean to reject the null? That is telling, does that mean, let's see, to reject the null, did the data provide sufficient evidence to conclude that these youngsters or more youngsters are getting high? Or experimenting, if you will? Can we conclude that? Shame on you guys. Just kidding. Yes, the data does provide sufficient evidence that there has been an increase in the marijuana/hashish usage amongst 18 to 25-year-olds. So we can make that conclusion.